All right, so interpreting graphs worksheet number one, I'm just going to go over this first question. You're going to realize that these problems are very similar to those velocity acceleration type problems. Sorry, not acceleration, but those velocity total distance type questions that we had done earlier in the year. We're not going to ask like where is velocity increasing or where is something slowing down, but the understanding of that is what's going to help you answer these questions. So for problem number one, water is pumped into an underground tank at a constant rate of 8 gallons per minute. So this is the rate of which water is going in. Water leaks out at a rate, let me switch the color out. So water is leaking out at a rate of square root t plus 1 gallons per minute for time being between 0 and 120 minutes. At time t equals 0, the tank contains 30 gallons of water. So that's just telling me what I'm starting off with. So here we have a graph that's already been given to us. Now we're going to highlight some sort of important information from that. We have water being pumped in at a rate of 8 gallons per minute. So notice that our y-axis here is rate. So when I'm looking at these y values, the y values are not telling me how much water is in the tank. The y values are telling me at specifically that time, at time being 80 minutes, the rate at which water is going in and the rate at which water is going out. So I want to start by labeling these functions. This one, the one that is just a horizontal line at 8, is the rate at which water is going in. My other function then, the one that's sort of this curved one, is my square root t plus 1, which is the rate at which water is going out. The 30, notice that 30 isn't really part of this graph at all, because the 30 is how much water I'm starting with. And this is on our y-axis rates, not the amount of water we have. So it does say right here, the numbers that are written in each region represent the areas of the region. So what this 96.5 is the area of this region. The 63.5 is the area of this region. Well, why do we really care about area? You know, if I were to take some, let's just say this rectangle. If I were looking at this rectangle, an area of a rectangle is found by doing base times height. If I were to multiply the base, which is in terms of minutes, times the height of this rectangle, which is in terms of gallons per minute, minutes would cancel and I'd be left with gallons. So what that tells me is when I'm finding the area underneath one of these equations or one of these functions, what I'm really finding is the amount of water. So if it's underneath this in function, that's the amount of water that has gone in over time or over whatever interval of time. And if it's underneath the out function, it's the amount of water that has gone out. So that's why these area values are going to be important to us. So part A, how many gallons of water leak out of the tank from time 0 to 20? So first, it's important to realize that I'm only asking about how much leaks out of the tank, which means that I'm only concerned with this out function. So this is the only equation I really care about because I'm just talking about how much went out. And I'm only looking from 0 to 20. So I'm looking at from this interval, 0 to 20, how much has gone out. So I would just want the area from 0 to 20 underneath this curve. And that area is already given to us, 63.5. And always make sure to include units, gallons. So no work there. For part B, how many gallons of water are in the tank at time t equals 20? So here we have to account for a couple things. We have to account for how much water has leaked out. We also need to account for how much water has gone in and the amount that we initially started with. So let's start with that. We know that we have 30 gallons. Now there's going to be two different ways that we can do this. So I'll do it the longer way. This is not the way that I would regularly do this problem, but I'm going to start like that. If I want to talk about, okay, I initially had 30 gallons. How much went in? Well, if I look at my in function, that's this function. And I would want any of the area that's underneath that. So I would take 96.5 and add that, because that's water that's being pumped in, and 63.5 and add that, because that is also still underneath this red function, the in function. I also need to account for how much water, though, also leaked out. So if I'm looking at the out function, my blue function, the area underneath that is 63.5. So I would take that away. Now you can notice here what that really means is just this portion is just canceling. So we're left with 126.5 gallons. Now, as I said, this isn't exactly how I would usually do this. What I would usually look at is, okay, we had 30 to start with. And then instead of factoring in everything that you gained and everything that you lost, I look at it as just overall, from the time 0 to 20, was there a net gain or a net loss? And you know that based whether or not the rate at which you're going in is larger or smaller than the rate at which water is going out. So from 0 to 20, water was going in at 8 gallons per minute. Water was leaking out somewhere less than that, somewhere between like 2 and 5. So what that means is just overall, I was gaining water. The amount of water that I gained then is just the area that's in between those two. Because this 63.5, that's underneath both, which means that I gained it, but then also lost it. So I would just be looking at this as 30 plus 96.5. I wouldn't even factor in the 63.5. So 126.5. Same answer, just going to be a different way in which you guys can think about that. All right, for part C, how many gallons of water are in the tank at time t equals 120 minutes? So now we're just saying, instead of looking at just this small interval, if we talk about that whole time in which time elapsed. So I'm going to start with the 30 that we already know that we have. We've already determined that between time 0 and 20, we've gained 96.5. Now if I look from 20 to 63, from 20 to 63, overall, there was a net gain. And I know that because this gain function from 20 to 63 is higher than the loss function, the blue function. So I'm going to add in this 66.8. After time being 63, my out function, the rate at which I was leaking water, is larger than the in function. So I know that from 63 to 120, there's going to be a net loss, and it's going to be a loss of 90. So then I just calculate all those areas. I'm going to add them up real quick using my wonderful calculator. So we get 103.3. And again, including units, gallons. And then last in part D, at what time t for time being between 0 and 120 is the amount of water in the tank at a maximum. So I'm going to have to evaluate, essentially, this could occur at one of 3 locations. This can either happen, let me switch to black. This can either happen, whoa, gosh, that is not black, that is rainbow. Oh, wrong pen. So this could either stop or happen right at the beginning. So right initially when I have that 30 gallons, if I've lost from that point on, that would be my maximum. It could happen at the end. Maybe overall, I've put in so much water that my maximum happens at the end. Or when I switched right at 63, I changed from gaining to losing. So it's possible that that could be a maximum as well. Any time in which I'm switching from a gain to a loss or a loss to a gain, that can be a minimum or a maximum. So at time t equals 0, we already said that that was 30 gallons. At time t equals 120, we said that that was 103.3 gallons. So the only thing we really have to calculate now is time being 63, which just means essentially if we're looking at that previous work, this was the interval from 63 to 120. So I would just add that 90 back in. So I'd have 193.3 gallons. And then it's asking at what time is the amount of water at a maximum. So it would be at time t equals 63 minutes. The water in the tank, is at a maximum. Now, you're going to see some other styles of questions throughout here because, you know, in these two, really in these three, we talked about the net amount of water, but we're also going to ask questions about like how much was lost, how much was gained. So, you know, in this case, we talked about how much was lost. That meant that we were only factoring in values that were underneath the loss function. If I ask you how much is gained, I'm asking you only how much is underneath the gain function or the amount that's put in, how much is pumped in. And then if I'm asking about how much water there is, I'm asking you about a net change. So it's factoring in both of those. All right, that's the only question that I'm going over. The rest of them are just homework problems for you. You'll turn those in an assignment not due this week at all. It'll be due on Monday. But any questions that the three of you have before I let you go?
So for t equals 63, so you just, so when you're finding that, it's everything behind the 63, so that's why you just added the 90?
Yeah, because you'd be saying you started off with 30, added 96.5, added 66.8, and we're only caring about what's happening up to 63. So you don't factor in the 90.
Oh, okay. Okay.
Does that make sense?
Yeah.
All right. Anything else? All right, then I'm gonna stop that recording so that we can get that posted. Once I figure out